Oh, my stuff kind of went up into the one above it. All right, so we had 4 vocabulary terms so far. We had the triangle inequality theorem. Again, just reviewing that, it is that if we have the sum of any 2 sides has to be greater than the third side for it to be a triangle. Okay? Pythagorean theorem is where we get our a squared plus b squared is equal to c squared. It's saying that c squared, the area of a square formed off of the hypotenuse, is equal to the sum of the squares that it's created off of the legs of a right triangle. And then we have the 45, 45, 90, and the 30, 60, 90 triangle theorems, which each had more of a diagram, but on the 45, 45, 90, each leg was equal to each other, and the hypotenuse was equal to the square root of 2 times the length of one of the legs. On the 30, 60, 90, as we did at the beginning of here, it was the short leg is your primary, that's your x, and then the hypotenuse is twice the length of the short leg, and the long leg is square root of 3 times the length of the short leg. What the 3 that kind of on this slide, they scrolled up somehow into my 30, 60, 90 one are 3 that we're going to be dealing with today. The first one is sine ratio, and it is not spelled like a sign you see on a street corner, right? It is spelled S-I-N-E. The sine ratio says that if I'm given a right triangle, I'm going to label this just like A, B, C. From my given angle, all right, let's say this is 34 degrees, okay? All right, from my given angle, the sine ratio says I'm going to look at the opposite of that angle. So this is my opposite side over the hypotenuse. Okay, so I get this equation, sine of, I'm going to say C, sine of my angle is equal to, and it's here that I do my ratio, opposite over hypotenuse. Okay? And I could do the same thing for A, other than if I did A, my reference changes. Okay? I'm going to erase the 34 here. I'll just use the little stick figure. We're going to be using that as kind of our reference. Our second vocab word today is cosine. C-O-S-I-N-E ratio. The cosine ratio, we use similar language as the sine ratio. We're still going to have a triangle here. Still going to label this as A, B, and C, and this is a right triangle. So I'll keep my reference similar or the same. So here's my little stick figure guy that says I'm referencing angle C, or that vertice. So cosine states that I can get the cosine, cosine of C, cosine of that angle, is equal to the adjacent. So this is the leg that is adjacent to that angle, over the hypotenuse, and our last vocab is tangent ratio. And again, I'll do a triangle here, a right triangle of A, B, and C. I'll do my stick figure here referencing angle C. Tangent ratio, says I can say the tangent of angle C is equal to the ratio of opposite and I'll kind of shorten my letters here, opposite over adjacent. Okay, opposite over adjacent. And there are some ways of remembering these sets of ratios by creating a mnemonic. The one that's used the most for this, to remember the order, is SOHCAHTOA. SOHCAHTOA. So the way this reads is sine is the S, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. And so that is a way of remembering that. There are also other things of where if you think about sine, then cosine, then tangent, just like the way I went through the vocab words, you can just look at the OH, the AH, and the OA, and you can make something up like Oscar had a heap of apples, okay, or something like that. Okay, you can make up your own. Making up your own mnemonic actually works better than taking on somebody else's, because you've made it, and so you're going to remember it better. Okay. So let's do some examples here. All right. I have a triangle here for my first example, ABC, and I have my little stick figure guy down here that has a question mark over his head, like, what am I supposed to do? Okay. How do I determine the trigonometric ratio? Because that's a really important thing. If they're looking at sine or cosine or tangent, right, they're going to ask you or have you be looking at a specific angle. And so notice I put my little stick figure guy down here at A because the problem said, well, what is the ratio of sine of A? Okay. Well, if we remember the prior slide, sine of our angle, in this case I'll say A, because that's what they're wanting. Sine of A is equal to opposite over hypotenuse. So one of the reasons to put a little stick figure is think about you being that little stick figure and saying, what side is opposite me? If I'm standing at A here, what's the side that's opposite me? What leg is opposite? Well, the leg that's opposite here is this BC, which is 24. So my sine of A is equal to 24 over, well, hypotenuse, that's always the side opposite my 90 degree. It's always the longest side. So that's 24 over 40. So this ratio here of 24 over 40, that is our answer. You can reduce this down, right? It will not change your answer. So I could reduce this down 12 over 20, 6 over 10, 3 over 5, right? I'm going to erase the rest of these. Okay? And you can even do it as a decimal, which in this case is 0.6. All right? Keep an eye out for what the directions say for how far to round it, right? If they're saying the nearest tenth or the nearest hundredth or the nearest thousandth, right? You need to make sure that you know that that's 1 decimal place, 2 decimal places, or 3 decimal places out, okay, and round accordingly. Number 2, cosine, right? Again, C is our angle this time, right? So that's why the little stick figure here is over by C. So cosine of C was adjacent leg over hypotenuse. That was our formula for cosine. So if this is where I am up here at C, the adjacent leg, remember the legs are the things, the two sides of the triangle that make the 90. So the adjacent leg is this leg right here. This is my adjacent, A. Okay, that's my adjacent. My hypotenuse is always opposite of my 90. 32 would have been my opposite side, so I'll just put an O there. I don't need O, so I'm just going to cross that out. The only two that I'm using here are 24 and 40. So again, I would have cosine of C is equal to, in this case, 24 over 40. Now they won't always be the same, right? These two example problems just so happen to use the same numbers. And again, that can be reduced down to 3/5 or given as a decimal of 0.6. Okay. Tangent of x for our third example. So I put my stick figure over here at angle x, because that's where my viewpoint, my reference angle, all right? And tangent ratio is opposite over adjacent. Okay, so the opposite side to where my little stick figure is standing, opposite leg, is this one over here, ZY. So I'll put an O. Well, that kind of looks like I made that into a 50. So let me put that kind of above him. So this is O. My hypotenuse is across from the 90. And my adjacent is next to my angle. So I'm dealing with opposite and adjacent. I don't need the hypotenuse, so I'm going to cross that out visually. So my ratio for tangent of x is my opposite, which is 5, over adjacent, which is 12. That can't be reduced any further. If it asks for exact, give it as a fraction. If it asks for you to give it as an approximation, round it to whatever it says. So in this case, 5/12 is 0.4166 repeating. All right, so round, if it's saying round it to the nearest hundredth, right, that would be to this point right here, 4/1. So, all right, the 1, the 6 is greater than 5, so by rounding that to the nearest tenth, tangent of x would equal 0.42, and that would actually be an approximation, not an equals. So we have some wavy lines there. So how do we use those trig ratios to determine unknown side lengths in right triangles? So this should look somewhat familiar, as this was your first essential question, all right, for today. So in question 4 here, I have my little stick figure at my known angle. Okay, they gave me this 29 degrees for angle for this angle over here. Okay, they aren't labeled. I could go A, B, and C if I so wish. Okay, but the angle they give me is the angle that I'm going to draw my little figure on. Okay. So if I look at this figure and I say, from this figure, what are my sides? So x is going to be what side in relation to my figure? Okay. So this is our the x, this AC, right, or our x here, that's opposite our right angle, so that's always our hypotenuse. Now, with reference to our figure here, right, what is AB? What is this side of 19?
The opposite.
That's our opposite, so I'm going to put an O there. And what about BC, this side that nothing is said anything about?
The adjacent side.
The adjacent. So I'm just going to put an A there. Okay, so we have an H, an O, and an A. So on this one, what we want to do is we want to look and we want to say, all right, from this angle, what two sides do I have anything written about? I have something written about H, my hypotenuse. It's X. It's an unknown. It's obviously something that the writers of this problem wanted us to solve. The opposite has something written on it. It's 19. So it's obviously something that, is useful. And BC has nothing written about it. So we aren't going to use it at all. So we're going to actually cross out our A, the side that nothing is written about. Okay? So that means the only two sides that have information that's relative or relating to our problem is opposite and hypotenuse. So which sine function then deals with opposite and hypotenuse? The sin or sine, right? So we have sine of, I'm going to use that angle, 29, or actually I'll put it as sine of C is equal to, and the sine ratio is what? For those sides, we do what over what? Opposite over hypotenuse. And I'm just going to kind of abbreviate those names. Okay, so opposite over hypotenuse. Now let's plug in what we know. C, the angle C is 29 degrees. So I'm going to put 29 in there. And this is equal to, well, opposite is 19. And my hypotenuse is X. Okay? So to solve, now we need to solve for X. Well, right now X is in the denominator, so we actually have to multiply both sides by X, and then we'll have to divide. When we do that, though, an interesting thing happens. Okay? And here's the shortcut. X and this sine of whatever, I'm just going to say whatever for right now, because it doesn't matter the angle. When you have your variable on the bottom over here, okay, and you need to find out what X is, these two things are going to switch places. Okay? Because I'm going to multiply by X on both sides. Okay? I'm going to multiply X on both sides. That cancels out X on the right-hand side. So now I have X times sine of 29 is equal to 19. Well, I need to get rid of X, and this sine of an angle, that's one thing. Okay, so don't try and get rid of a 29 out of there. That sine of 29 is one component, right? One block. It cannot be taken apart. So I'm going to divide both sides by sine of 29, which cancels sine of 29 off from the left. And that gives me X is equal to 19 over sine of 29. Okay? Sine of 29. We're not going to leave it as 19 over sine of 29. We actually need to put this into our calculator, right? And it's really important at this point to make sure that your calculator is in degrees. That is a key thing that you have got to remember, is to always check your calculator and make sure that it is in degrees. If other people have used that calculator, it might have gotten transferred because other classes use calculators, so it might be transferred over to radians or something. Make sure that it is in degrees, because if it isn't, you're going to get your answer wrong. Okay? So I take 19 and I say divided by, and then on my calculator I hit, there's a little SIN button. So I hit sign, I put in the 29, and then hit enter. All right? And what I get here is that X, this side here, up here, is approximately 39.19, and I'll round it to the nearest hundredth there, 39.19 units long. Okay, and that would be our answer, 39.19. Our next example, all right, we're given this angle here of 19 degrees. Okay, so again, I put my little stick figure by the angle that's given, and I go and label my triangle. So 19, the side of 19 is which side?
Opposite.
It's my opposite side, so I'm going to put an O there. This side of X is which side?
The adjacent side.
Adjacent, and this side that we know nothing about is our hypotenuse. So I'm going to put an H there. All right, so the only one that we don't have anything about is our hypotenuse. So I'm going to cross that out, just so that visually I know I'm not going to be using anything with hypotenuse. Well, that means I'm only using opposite and adjacent. So if we looked back at our three types of ratios, there's only one ratio that doesn't use the hypotenuse, and that's tangent. Okay? So tangent of my angle, I'll just say A, is equal to, well, the ratio for tangent is opposite over adjacent. Okay? So if we plugged this in, plug in our information. I have tangent of my angle, which is 19 degrees, is equal to opposite 19 over X. Well, knowing what we know about when we have that variable on the bottom, right, we could go through the double, division and multiplication and da-da-da-da-da and get X all by itself on one side. Or you can apply the shortcut, which says only in cases where your variable is on the bottom of the ratio can you flip or switch these two things out. So tangent of 19 would switch with X. Okay, so I'd have X is equal to 19 over tangent of 19. And I would plug this into my calculator, just unless you have a Sharp or Casio, you might have to put it in the other way. But on any other Texas Instrument, you should be able to say 19 divided by tangent, which is the TAN button, and then 19, and hit enter, and you get that it is approximately 55.18 units long. And that would be your answer. 55.18. The last one for ratios for sides. Okay, so in this one they give us an angle of 62, right? And so I put my little stick figure by that. And then from there I can label my sides. Right? The two sides we have information about are the adjacent and the hypotenuse. Okay? Yeah, cosine, cosine of my angle is equal to adjacent over hypotenuse. Okay? And it's actually a lot nicer when your variable is on top, but on all three of these it just worked out to be on the bottom. If it's on the top, all you have to do is multiply both sides by whatever that number is on the bottom. And so you'd have that number times cosine of, or sine or tangent. So in this case though, we have, again, cosine, and then put in our degrees, which is 62, is equal to 18 over x. I'm able to switch or swap cosine of 62 and x so that they're in each other's position. X is equal to 18 divided by cosine of 62. We plug that into our calculators. Those of you with other calculators that I've talked to, you would go 18 divided by 62 cosine equals. Everybody else just goes 18 divided by cosine of 62 equals. And that's going to give us an answer of 38.34. 38.34 approximately. Okay, so that would be my answer there. Okay, 38.34. Again, absolutely need to have these in your notes, right? That the trig ratios include sine, cosine, and tangent. Okay, the ratio, whichever ratio you're using, that is determined by the relationship to that given angle. Okay. Whatever angle that they're referencing, draw your little stick figure. That's the angle that is going to determine your ratio. Make sure your calculator is set to degrees, otherwise you're going to get your wrong answer. Remember what the ratios are, whether that's through the mnemonic that you create or the SOHCAHTOA, right? Sine ratio is opposite over hypotenuse. Cosine ratio is adjacent over hypotenuse, and I think it kind of cut off, but tangent ratio is opposite over adjacent. Okay? So now let's answer the second question, our essential, which is how do I determine an angle measure using inverse trigonometric ratios? So let's say we found a ratio, right? And we did our division of that ratio, and we got a decimal to 4 decimal points, okay? To 10 thousandths. All right? Well, how do we figure out what basically in this case z is, right? Because we want to know what z, how many degrees z is. So what you use for this is the inverse. So on your calculator you have the sine, the cosine, and tangent button. And above those you have the sine to -1, cosine to -1, and tangent to -1. And so you're going to use those, and you're going to take, and this, like for this example, we'd actually take the inverse sine, which is what that -1 means, of whatever that ratio was. In this case we do 0.9994. Okay? And by doing that on your calculator, so if I did second inverse sine of 0.9994, that gives me, if I round it to the nearest whole number, that means z is approximately 88 degrees. Okay? Tangent of w, so I would, instead of sine, right, it's saying tangent. It already gives me the ratio, so I know w should equal the inverse tangent of whatever this ratio is, so 0.0175. So I can plug that in. Second inverse tangent of 0.0175. And so that actually says, well, w is really, really small. It's actually 1 degree, approximately. Okay? Cosine. So if I'm dealing with cosine here, to find what c is, I'm going to use what? If I follow the pattern. Instead of sine, I used inverse sine. Instead of tangent, I used inverse tangent. Instead of cosine, I should use inverse cosine. And I'm going to do inverse cosine of this ratio, so 0.8829. Okay? So second inverse cosine, 0.8829. Round it to the nearest degree, which is, in this case, c is approximately 28 degrees. For example, I'm going to do sine, cosine, and tangent on this problem. Okay? So here's my angle that I need to know. So I'm going to draw my little stick figure. So that means this is my opposite side, this is my hypotenuse, and this is my adjacent. So sine of my unknown, right, is equal to opposite over hypotenuse. So I have 56 over 70, which gives me 0.8. Okay? If I take now the inverse sine of that answer, that gives me what my degrees are. Okay? So my answer should be 53 degrees. So this right here was 53 degrees. Okay? Cosine, let's say you don't like sine, you like cosine better. All right. Cosine uses adjacent and hypotenuse, so that's 42 over 70, which is 0.6. So if I used cosine to get the ratio, I would use inverse cosine to get the angle. So again, 53 degrees. Same with tangent. Tangent of my unknown angle is equal to, well, that's opposite over adjacent, so that's 56 over 42, which is 1.3333. Take the inverse tangent of that. Is 53 degrees. Notice all three are the same degrees. Oops. So 3 key concepts of this were that the ratios are the same, right? Whether you're dealing with inverse or regular trig, the ratios are still going to be the same. Each ratio is determined by the relationship to the needed angle. So, look for that question mark angle, or that x or a or whatever variable they're using for the angle, and make sure you write your little stick figure for that angle so you can determine which sides to use and therefore which ratio to use. And more than ever, make sure that your calculator is set to degrees, because by finding the angle measure, if it isn't set to degrees, you will be getting it in radians or gradians, which will give you the wrong answer. If you're watching this because you weren't in class, or you missed a good majority of class due to the SBAC, that's okay. You can get your assignment either from me at my desk in Lower South Teacher Cluster, or you can get it at the top of the web page on the right-hand side. Just look for the little paper clip for Trigonometric Ratios lesson.